Number 6 says, write two equivalent expressions that represent the total area of the rectangle below. And remember, we practice this a lot. You can either write it the total width times the total length. So here the total width is 15 plus x, and the length is 8. So that's one expression for area, right? Or you can do the individual areas added together. So 8 times 15 is 120. X times 8 is 8x. And so you could have written it 120 plus 8x. So these are two different ways to write that area. And if you notice, it shows distributive property. 7, are the expressions equivalent? Write yes or no. And then use an area sketch to prove. So notice that this is slightly different. This is, number 5 was, are they equivalent? But we used methods like algebra, algebraic reasoning, or substitution to talk about those. But on number 7, we're supposed to be using an area sketch to prove it. So are these two equivalent? So I'm going to say no. I'm looking at this, and this clearly doesn't use the distributive property. So I'm thinking algebraically, but if I want to prove it using an area sketch, this one I would draw an x and an x. So here's an x. And here's an x, right? And here we'll call this a 3, right? So then that would need to be x squared right here, and that would need to be 3x, right? So that's not the same thing as x plus 3x. So this is the area sketch that proves that they're not the same. This one, I'm saying yes. Again, I'm looking algebraically and see the distributive property is true. But proving it, again, let's make a rectangle with width 2 and a length of x and 5, right? So then this little area in here would be 2x, and this area would be 10. So we can see that if you add these two together, it's going to give you the same thing as the length times the width.